Today I'm going to try to write an assembly language program which writes to the console. Just a reminder to anybody watching my videos, I'm mainly making these videos for myself. I'm a noob when it comes to assembly language programming, and I want to record everything I have learned so far so that when my fad for assembly language dies and I go on to some other fad of mine and then I return, I can watch these videos and relearn what I now know. Otherwise, I end up having to go through all the resources again, wasting a lot of time. So if you're going to follow these videos, just know they're not meant to teach you. They'll have mistakes, they'll probably have concepts which are all wrong. You're probably better off learning assembly language from someone who truly knows what they're doing and not someone like me. So to write something to the console, we're going to need two functions. And if we're going to need these functions, we're going to have to prototype them here. One of the functions we need is WriteConsole. So let's type that out. Second function we're going to need is get standard. What was it called? It's called get standard handle, get std handle, this function here. So these are the two functions we're going to need to write to the console. Let's look at get std handle. Why do we need get std handle? Because apparently WriteConsole wants a handle to the console output. Without this handle as a parameter, WriteConsole won't work. And to get this handle, you need to use get std handle. Now here are the values which get std handle will take as a d word as its parameter. The standard device, this parameter can be one of the following values. You can get the input handle, output handle, and then there's the error handle. Since we're writing to the console, we want the output handle. Had we been reading in from the console, then we would have wanted the input console, input handle. So the value here is negative 11. This is what we'll be using. So let's first get the output handle. So here between the shadow space, because you need the shadow space when you're calling on Windows API functions. Otherwise, I mean, they'll work. Sometimes they work, sometimes they don't, but it's the Microsoft API convention, and you need conventions if you're calling on functions to create harmony. Otherwise, the other program isn't going to know what you're doing. You're going to be sending it data formatted in whatever way you like, and it's not going to know how you formatted it. So you need a convention where you both agree on how the data will be formatted so that you're on equal grounds, and that's really the purpose of the Microsoft API. So we've subtracted 32 bytes for the shadow space. Now the first parameter for any Windows API has to be loaded into RCX. So we shall move into RCX -11. And that's really the only parameter it needs. And then we call the function. And the return value will be in RAX. So let's see if we get a return value in RAX. Here we'll create a breakpoint, insert breakpoint, and if you're as dumb as I am, I'm very dumb. I'm very slow and I'm very dumb. Maybe it's because I'm so old. You insert a breakpoint, and what's going to happen is the program is going to run till the breakpoint and it's going to stop. It's actually now going to execute where you place the breakpoint. And the purpose is to debug, so you can look at the registers, the values, and whatever you want to look at. So let's run this in the debugger, see if we get any errors. Doesn't seem like it. And if you look at RAX, it has a value of C in it. It's loaded in the output handle into RAX. Now we could take this value of RAX and set up a variable in the data section and store it there. I think we will, just for practice. You don't have to. You could just use RAX. In the next Windows API, you could load it into RCX, because that's the first parameter that WriteConsole requires. But let's just load it in. But before we do, let's run the program to see if we have any errors. Nope, it's working fine. So if we look at the handle, it is a 64-bit or 8-byte return value. That's what a handle is. It's a return value which is 64 bits or 8 bytes. So if we want to define space for it, we're going to need to use a keyword. And a keyword is defined with DQ. So let's name it HHandle, and DQ would define quad word. And since we don't know what the value is, we are taking in the value, we leave it uninitialized. Now if you want to move it into this from RX, we do move. We use the open and close brackets, which tell the assembler that we want to place the value into the HHandle variable. And then we simply do RAX.